Welcome back. We're going to start digging into two new topics today, ones that weren't covered in 1060 this time, operator overloading and friend functions. And I encourage you, if you haven't already, to actually check out my notes on the subject. If you haven't been following along, there are a set of notes that have been posted on Jupyter, and you can read up, for instance, on these two topics with some notes and some code provided with examples on these two things. So without further ado, let's get into the exercises. So the first exercise says make a star class with attributes including brightness and mass. We're going to overload the plus operator to combine the brightness and mass of two star objects. Okay. So let's make a new file, exercise 1, without the txt. And here is what we're doing. Okay. So I need a class called star. It's going to have, I guess we'll keep things public just to save on some effort in writing getter and setter functions and all that, but probably it'd be better to make these public attributes. But for now, let's do double brightness and double mass. We'll make a star constructor to save ourselves some headaches, so we can do star, let's see, the parameters are going to be double B and double M for brightness and mass, and there's a shorthand you can use for making a constructor. We've seen before we might do something like brightness equals B, mass equals M, but if you're looking for a quicker way to write it, you actually can do something like this, brightness B, mass M, and this will directly assign those parameters to these attributes of the class. Just to make sure I haven't done some nonsense here, let's make sure I can make a star. Star S equals star. Its brightness will be 10.5, mass 2000. Sure, why not? Now, can I compile you? Exercise 1 into star. Oh, did I forget the, I think I have the wrong symbol here. I think it should be this. Is that right? There we go. And just to double check that it assigned these correctly, let's output some of these properties. Can I do s.mass, and I should be able to get 2000 to appear? Looks good to me. So far we've made a star class that's got attributes for brightness and mass, And when I use my constructor to give it a brightness and a mass, it assigns that brightness B to the brightness and assigns that mass M to the mass. And I don't need any other code going on, so I can just leave that as it is. Now, to overload the plus operator, what I want to be able to do is make two stars and add them together. So right now I got S, let's do S1 and S2. And star 2 will be, let's say, twice as big as the other. And I want to be able to do something like star S3 equals S1 plus S2. Now, right now, if I do this, the computer is going to be pretty upset at me. And here's what it's going to say. A whole bunch of stuff. Maybe I'll clear it, and I'll start from the top. But here is the issue. There is no match for operator plus with operand type star and star. And what this means is that the computer doesn't know, how do I add S1 and S2? They are two stars, and we want to define what it means to add them together. But right now, we haven't told the computer how do you do that. So here's what we want to do. You'll notice, in fact, in the error message, it actually tells us the name of our function. The name of our function is operator plus. And this literally refers to the plus symbol. The parameters here are two. One of them is the S1 star, and one of them is the S2 star. Now, what's the return type of this? Well, it depends on what you want. You could have it be where when you add them together, the result is a string. You could have it be an integer. It can actually be anything you want. In this case, if I want to mesh two stars together, I just want to have a big star. So we're going to make a star be our return result of this. And we'll say star S3 equals star, and the brightness for this is going to be S1 dot brightness plus S2 dot brightness. So this is going to be the brightness of my new star, and the mass of my new star is going to be S1 dot mass plus S2 dot mass. To make this a little more legible, I'll split it up a bit. And we'll return S3. And now when I add these together, I'll have it S3, and we'll output its properties. In fact, I'm probably going to be outputting the properties of stars quite a bit, so let's make a method for that. Let's do a string method for it so that we can generate a string from a star. So we'll call this toString, and we won't have any parameters for it. And what it will do is make a string result. This star has a brightness of result plus equal. Let's add a space here. We'll add the brightness as a string. Now this toString function is the one built into C++ that converts doubles into strings. It's not the same as the one I'm defining right here. We're going to add the brightness, result plus equals, and a mass of, and then we'll do toString of the mass, and return our result. And now I can use star.toString to create a string. And so when I want to output the details of my star, I can say cout s3.toString. Let's see what happens. Let's clear this up first. Compile. Okay, what is my issue? I think I messed up something along the lines here. Oh, here's my problem. Let's see. I think I'm missing up the amount of arguments that are here. So right now I have operator plus star S1 star S2, but I don't think that's what I'm looking for here. And the reason for that is that I already have a star that I'm adding to. So when I have star operator plus, I think I only actually need my S2 star. And my S1 is actually the star that is using this operator, so I should be able to remove S1, and it'll take the brightness and mass of the star being added to S2. Let's try this out. Almost. Now this might be a case where the computer is getting kind of upset that I am using toString a couple times. So to fix this, I think I might want to use my star, to have my star have a different method. So I'll have this be called toString without a underscore and with a capital S, and I'll do the same over here. Let's see if that helps. Okay, and now I have no errors. So here's the two things I fixed. The first one was when I made my overloaded operator, I originally had star S1 and S2. That's not quite what I was really looking for. And the reason for that is that when I am using the plus symbol, there's already a star on the left side of my plus. I'm not defining what it means to add, say, 5 to a star, because what is the sun plus 5? That doesn't make any sense. But if I want to combine two stars, I'll mesh them into one thing. Then I want to take the original star, which has a brightness and a mass, and add that brightness to the other star's brightness, add that mass to the other star's mass, and use that to construct a new star, which we'll call S3, and that's what gets returned. When I go down here and I say S3 equals S1 plus S2, S1 is a star, we go to its overloaded operator plus method, passing it S2 as a parameter, and we add those elements to create star 3. The other issue I had was that I had originally called this method toString with an underscore and a lowercase s, There already is a toString method in the standard library called toString, and now the computer's kind of annoyed because I did say using namespace std, but that's further away than the toString method I literally started writing right here. So to avoid any kind of overlap between these methods, we'll use a capital S toString here to represent a toString method that belongs to my star, and to_string to refer to the built-in C++ method that converts this double into a string. Now when I run this, you can see the star has a brightness of 31.5 and a mass of 6,000, which comes from adding these two together, exactly as I want. And that's our first exercise. Then we can move on. Okay, next step. Overload greater than or less than, greater or equals, and less than equals operators for the star class to compare the masses of two star objects. Okay, so we're gonna have a whole bunch of overloaded operators here, which is not a problem. So first of all, for each of these, the type is going to be the exact same thing, which is a Boolean. It's either true or false. When I compare two stars, say to see if one's less than the other, and I can actually do this very, very quickly. I simply return if and we said I think we're comparing the mass. Yes, compare the masses of the star objects. So if the mass is less than s2.mass, then this should be true. Otherwise, it should be false. And I can quickly copy this for all the other operators we're working with. So here is less than or equals. Here is greater than and greater than equals. And again, to confirm this works, we should take a look at our stars that we've created and see which ones are bigger than the others. So we'll see if S1 is less than S2, and if S2 is greater than or equal to S3, and if S3 is greater than S1. Sure. And for each of these, I will ask the question, is this true or false? And if it is true, I will say, or here, we'll output all of these things. So output, output, output. Some parentheses. If this is true, output true. Otherwise, false. And do the same thing for all three. So now this will print out true or false for each of my three comparisons. Just for the sake of knowing what those comparisons are, let's print out what those comparisons are. So we have, is S1 less than S2? Is S2 greater than or equal to S3? And finally, is S3 greater than S1? Before we run it, let's predict our answers. The mass of S1 is 2,000, the mass of S2 is 4,000, the mass of S3 is the biggest. So S1 should be smaller than S2. S2 should not be bigger or equal than S3, but S3 should be bigger than S1, which means you should get true, false, true if this worked out correctly. True, false, true. Exactly as we want. And you can see it was very quick to make all these operators. They're all just really copy-pasted from the other one, and all we're doing is a direct comparison. However, without these functions here, the computer will have no idea how to actually compare anything. They give me lots and lots of errors. It has no clue what's going on, which is why you need to be able to overload these operators if you want to be able to write this kind of really short code down below. Next exercise, we're going to overload the minus operator to calculate the difference in mass between two star objects. We'll overload the star operator to take an integer and create a star that has that many times more brightness and mass than the original one. Okay, now first of all, I forgot to make this a new file. So I'm going to duplicate this as exercise 2. And then for exercise 1, I'm going to remove the operators that I made. Like so. just to keep track of my, my progress. So here's exercise 2. This is where we were. And now we're going to proceed on from here by making a duplicate of this called exercise 3. Okay. Overload the minus operator to calculate the difference in mass between two star objects. So this says specifically the difference in mass. This means we're not trying to generate a star this time. We just want to know what the difference is of the mass. So the difference is going to be a double. The operator is a negative. We're going to take another star. We're going to return the mass minus S2.mass. To make sure this works, we'll take S3, which we know to be bigger, S3, and subtract S2, which you know to be smaller. And the mass difference is S3 minus S2. And we should see that the difference is 2,000 because we added 2,000 to 4,000 to get 6,000 for star 3. Let's see if that's true. Oh, did it not? It didn't print out. Oh, because I'm compiling the wrong code. Let's compile the right code, shall we? Differ. There we go, a mass difference of 2,000. Exactly as we like. Now, the second part was overload the star operator to take an integer and create a star that has that many times more brightness and mass. So star times 3 should return a star with 3 times that brightness and mass. So we want to make a star. I'm going to have operator star. Star. So the parameter for this one is going to actually be an integer, and it's the multiple. Unlike our other operators here, where we're taking a star as the other side of our expression, this time we're taking something like star times 3, which is going to look a little bit different. So in this case, I want to create a star that has that many times more brightness and mass. So 3 times the brightness, 3 times the mass. So star S2 is a new star where the brightness is going to be the brightness times the multiplication, and the mass is the mass times the multiplication. And we'll return that star. And let's see if I can make S4, which is S3 times 5. And we'll output S3.toString, or S4.toString. Oh, sorry. Oh yeah, that's right. And this one has a mass of 157.5, which is 5 times 31.5, and a mass of 30,000, which is 5 times 6,000. So there we have it. We multiply star 3 by 5 to get a 5 times bigger star. We can print it out. We can also do any of the same comparative operators as we saw before in order to play around with our new star object. There we go. Okay, last of these first set of exercises. Overload the arrow operator to output the attributes of the star class in a formatted manner. Okay, so this one's going to look a little bit different. I may mess up the formatting, so we're going to see what happens here. But the first thing that I'm going to do is duplicate. That's where I should start. It's exercise 4. Here it is. Overload the arrow operator to output the attributes of a star class in a formatted manner. Now, I want to do something different, which I haven't done for the other overloaded operators in the star class, and that is that I'm actually going to make this overloaded operator not part of the star class. I'm actually going to do it down here. Now, my operator is the 2 arrows. I know one of my parameters is going to be a star, S, but there's 2 parameters here. Anytime that you've seen these 2 arrows show up, if I want to do something like this, like my goal is to be able to do cout S4, and this should be able to show me some text. But here is my issue. What actually is going on over here? The right side is my star. What is the left side? Well, the left side is an output stream. It could be a file, it could be cout. But the type of this actually happens to be OStream reference, because we're passing by reference, and we'll call it OS just because output stream. And the type that we're returning is actually the same thing, OStream star OS. Sorry, OStream star. Or not star, asterisk, ampersand. I'll get it eventually. And what's going on here is you can think of this output stream as a substitute for either cout or for our file, which means that what we're actually doing here is we're just going to be directing all of our star information into this OS the same way we would into cout. So for instance, we'll start off by saying this star has the following properties. Brightness equals brightness, and then mass equals mass. And we're going to return this output stream. And what's going to happen is that when we go over here and try to do this, every time that we have these two arrows, it's going to convert that into something that can be sent to cout or a file or anything that we feel like. So now we should actually just be able to do this. I'll get rid of this to string approach. Okay, let's go. Sorry, exercise 4. Outputs. Right, it shouldn't be brightness and mass. It should be S dot brightness and S dot mass. And my outputs. See, the star has the properties that I mentioned before. So the nice thing of this is it means that I no longer have to do star dot to string every time I want to print out a star. I can actually just send it directly into the output, into cout, and it will give me whatever text I feel like coming up with. The formatting of this is really weird, and it is something you want to be familiar with if you plan on writing a lot of code like this. You need to include the fact that it is called operator arrow arrow. The type that's being returned is a reference to an output stream. The first parameter is also a reference to an output stream. You can call it OS, you can call it anything if you feel like it. And the second parameter here is the star itself. You'll note that we didn't put this inside of the star class, it's outside of it. And the reason is because the star class is not the one that's using this overloaded operator. It's actually every time I'm writing cout arrow arrow star, cout is on the left, not the star. It's not the same as me doing S1 less than S2. I'm not doing S1 arrow arrow S2. I'm actually sending stuff into output. And so that's why I need to use this slightly weird, but important to learn little structure. And there we have it. Okay, let's dig further. Modify the attributes of star to be private except for the star's name. We don't even have a name yet, so I will have to add that. Create a friend function, print star properties to access the private attributes of the star class and print them. Okay. So, let's make a duplicate. Duplicate. Let's close a bunch of these windows. We have a lot of them open. All right, modify the attributes of star to be private, except for the star's name. Create a friend function, print star properties to access private attributes of star class, print them. So here's what I'm gonna do. I'm gonna cheat because I'm the instructor and I can do so. We're actually just not gonna do this because you'll find that as soon as I modify the attributes of star to be private, there are things I'm gonna have to do. So I'm gonna remove that from there. I'm actually gonna remove that from here too. Whoop. We'll center this, I suppose. There we go. Okay, so first things first is I need to add a name because I don't have one. So string name, I need to add that to my constructor. String s, the name is going to be, or I should have it string n for name. Okay, and then I need to have my brightness and my mass be private. Now, this is going to introduce problems. Let's see where they start. Okay, first issue. Is building my stars is all wrong because I have a name now. So let's fix that when I make them. So this first one, we'll call this Soul. We'll call this one Sirius. And now we need to have names for other ones that we construct using our operators. So when we create one by multiplying, let's make the name be name plus x plus to string mult. Actually, what we'll do for now is we'll actually leave the name the same, and I'll figure out later what I want to do, which is I want to be able to do something like make it Sol times 5 if I make a 5 times the sun star. But we'll fix that later. And the same thing for over here. I think I'll worry later about how to correct the name here. Let me align these nicely. That's not aligned at all. Yeah, that's fine. Okay, so I have fixed the name issue, but there are other problems. Double star brightness is private within this context for this function. What's going on here? So now that I made brightness and mass private, it doesn't really affect most of these overloaded operators, except for one, this one. Now I have an issue. I can't access s.brightness because it is private. And there's a couple ways around this. One option is to make a getter and a setter for my stars so that I can retrieve and set these variables and then use them in this function. It is a bit clunky to do this all the time, however, and there's actually a much quicker way to do it, which is to indicate that this function here, which I'll copy exactly as it is a friend of the star class. And anything that's a friend of the star class can use its private variables. Which means now the errors are instantly gone. Being able to access s.brightness and s.mass, which normally is prohibited, is now allowed specifically for this function only. So s.brightness, which I wasn't allowed to give before, since it is a friend of the star class, can now grab these two private variables. And you'll see that my code should actually do the exact same thing. This is the exact same code as before. Okay. Now, let's move on. Create a friend function that compares the brightness and mass of two star objects and output which one is brighter and which one has more mass. Okay. Make another duplicate. Okay, so I'm making a friend function that's going to do some comparison of two star objects. So I'll call it compare, I suppose. It says it's going to, I think, print out things, so it doesn't matter if it returns anything, but it does say it's going to be a friend function. It's going to take two stars, S1, S2, and now I will define it outside of my star class. So this is a function called void compare, and it will say if s1.mass is, or we'll do brightness first, if brightness is greater than s2.brightness, output s1.name. Oh, and I should fix the my functions here. Right now I've been saying this star, but we have a name now. So I can say name plus this. And I can over here also have name this. We'll write our compare function in a second, but I want to make sure I compile this safely before I move on. Compare. Oh, it's not name, it's s.name. There we go. Okay, everything seems fine. Let's make sure I can actually see it now. So sol and sol. Let's see if I can also do what I wanted to do last time, which is fix up the name of my differently constructed stars. When I multiply a star, I would like its name to be name plus x plus toString mult. Let's see if we can do that. There we go. Now I got sol times 5 for multiplying it. And when I combine them together, I would like the name to be name plus space plus s2.name. Just for a little bit of, making it a little clearer how these stars are named. Now, that was just a little aside, not something we had to do, but something worth doing perhaps. Let's continue where we were, which was writing this compare function. Where were we? Down here. If S1 is brighter, then we'll say that star is brighter than S2.name. Else if it's smaller, then S2 is brighter. Else both S1 and S2 are equally bright. And I'll do the same thing for the mass, and rather than writing this all out again, because that would take forever, I'm just going to go here and replace brightness with mass. Mass, 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 heavier, heavier, heavy. Done. And now to compare, let's compare let's compare S1, S3, compare S2, S4, and that should be good enough. Let's compare. Sol Sirius is brighter and heavier than Sol. That makes sense. It's two stars combined together. Sol Sirius times 5 is definitely brighter and heavier than Sirius, for sure, because it's very bright and heavy. It's Sol Sirius times 5. Yeah, sounds good to me. Okay. Let's continue on. Create a galaxy class. Oh, like a ship. Containing a private array of star objects. Overload the subscript operator with the brackets here to access the individual star objects. Okay, so let's do that. And we'll do that over here, I think. Okay, so we made our star, and down below we'll have class galaxy. And it has a, let's say, a private array of star objects. Okay. So private. Now, I think again I will modify the parameters of the test as Captain Kirk would do, and make it a private vector, just to save ourselves a little bit of headache. So our vector of star objects will be called stars. And what else do I have to do? Oh, let's not make the mistake I made last time, which is I keep forgetting to duplicate my exercises. Let's undo that. Okay. Okay, continue with our galaxy. And it says that we are going to make a galaxy class. Private vector of star objects, and overload the subscript operator to access the individual star objects. Okay, so I want some public options here. Now, I definitely want a constructor. Actually, I don't really need a constructor. My constructor is just going to initially have an empty vector of stars, which is fine. But what I do want is some function that's going to actually add stars to my galaxy. This will be called void add star. It's going to take a star as a parameter. And all it's going to do is do stars dot pushback s. Um, okay, so I want to overload the subscript operator to access the individual star objects. So the overload operator is these two. The parameter is going to be a index. It's going to return to me a star. And so it should return stars of index. Now, if I did this correctly, I can do something like the following. Galaxy G dot, where is it? Add star. S1, add S2, add S3, and add S4. And then we're going to take our galaxy, get the, say, at the star at index 2, which is our S3, or third star, and we'll output that and see what happens. Let's get rid of a lot of this other output because it is a lot of unnecessary output. Comment that out, comment that out, and let's see how it goes. And this is going to be our galaxy. Okay, what did I mess up? Vector does not name a type. I may need to include vector. Let's see. Okay, that was my problem. It didn't declare the vector library, so it didn't know what vectors were. It's a bit of a problem. But now it can output Sol Sirius, which happens to be my third star I made by combining the Sol and Sirius stars together. It has all the other information. And yeah, so now I can retrieve the star from this. Now I don't think I can use this to modify the galaxy. I suppose I can check just for fun, but I believe the following will probably not work, which is G2 equals S4, and then do it again. I think this will mess up. Yeah, not quite. So unfortunately, and I'll double check just by doing S1. Yeah, so I am able to retrieve the second star, the star index 2 from my galaxy, but I cannot use this to actually go and assign that to something else. So just in case you were curious about the difference between just using like a vector specifically for this purpose, now obviously my galaxy class might have other things I want it to do, which is a reason for making a galaxy class, and I can use this to directly index the stars that are in my galaxy, but you can't use it, for instance, to reassign those elements to something different. I would need to be able to, I would need to have to go into the vector itself and reassign those things. So unfortunately, not quite available to me, but something that I could try to get working. Okay, it took us a couple minutes just to test something, and I was wrong. You can do this, and I made a very small mistake that meant I was not able to have this work. But this does work. It's just that I wrote the wrong code. So here I want to modify the star index 2 to be some other star, say index. Actually, maybe let's make it even bigger star. Let's take in star 2 and multiply by 100, just for funsies. Now, right now, this isn't going to work. So when I run, and I compile and go, you can see it didn't modify it. Why is that? Well, the reason is we're passing by value. In this function, the star that I'm returning is just a copy of the star that is inside of my galaxy. But I don't want that. I want a reference to my star so I can modify it. And we know how to add a reference. We add an ampersand. Usually we don't put it here though. Usually we put this as a parameter because we want to be able to modify the parameter itself, but you can modify the returned value too. By adding the ampersand in here, I'm now saying when I return the star inside of my galaxy, that I want that to be a direct reference to something I potentially can modify. And now what I'll do is I'll change that star into S2 times 100 and see what happens. And look at that. I now have Sirius times 100 with all of its brightness and mass. Thanks to the simple addition of one symbol I forgot to write in. But it's worth knowing it's there. Now, that's the end of exercise 7, and we're on to the final one. Exercise 8. Okay. Overload the function call operator, parentheses, in the galaxy class to output information about the galaxy. Also implement a friend function to access and output the attributes of any individual star object in the galaxy. Okay, so we'll do the first one and then we'll figure out the second one after. But let's start with the first. Overload the function call operator, parentheses, in the galaxy class to output information about the galaxy. Okay, so let's do that. So the operator is our parentheses. It doesn't need any parameters. This is a void function because it's going to output stuff. And for I is 0, I is less than stars dot size, it's a vector, I plus plus, output the, well, so first I'll say, I guess, here are the stars. And then we'll output each star one at a time. So let's stars I. And now if I go down here and I say G, and this is summary, did not seem to work. I think I have something going on that's not right. Oh, I did the same thing again. Always making the same mistakes here, modifying the wrong code. So that means that, let's see, exercise 8 has the code that should be for exercise 7. So let's copy this. Or here's what we'll do. We'll just rename these really quickly. Close this, close this. So this is going to be exercise 8. This is actually exercise 8. And this one's actually exercise 7. I'll fix those names up. Okay, so exercise 7 has the right code. And now I want to compile actually exercise 8. Summary. And here are the stars in the galaxy. Sol, Sirius, Sirius times 100, and Sol, Sirius times 5. Now, if you look all the way down, this looks like a function call. It looks like I'm calling function G. But remember, G is actually named my galaxy. And when I do G with parentheses here, what I'm doing is I'm actually saying, hey, go to my overloaded operator, which is this. I'll space this out to make it a little more obvious. So this is the operator. It's the two parentheses. It returns nothing. It takes no parameters. And it just outputs here the stars of my galaxy, using the fact that I know how to output each individual star. So that's part 1. Implement a friend function to access and output the attributes of any individual star object in the galaxy. Okay, so a friend function to access and output the attributes of any individual star object in the galaxy. I'm trying to figure out what I meant by this question. So I think what this means is it wants to have a friend function. Now, so this is going to output stuff. So it's friend void, returns nothing. Output the attributes of an individual star object. So it's output attributes an individual star object. And what is my parameter for this? So I'm trying to think of when I would want to do this. Access and output the attributes of any individual star object in the galaxy. There's a couple options. One is to pass it a star itself, but then at that point, why do I really need this, right? Maybe one way we can do it is by... This is a friend function too. So this is a function that's going to need to probably take a galaxy as a parameter. galaxy G let's say based on its index, or by index. By index. I think I probably could have worded that question a little better, but it's okay. Sure, we'll make a friend function. It'll access and output attributes of a star in the galaxy based on the index. So we're given the galaxy, we're given the index. So we got void, output attributes, galaxy G, int index. And what we can do is actually solve this in one line, because we can output the galaxy's index. I don't even think we need this to be a friend function, to be perfectly honest. We also can do something like g dot stars of index. This should work as well. Not a problem. Let's output the attributes of, let's say, G number 0, the first star, which should be Sol, our first one. There's Sol at the end, after it does the summary of all the other ones that are there. There's a couple ways that we could do this at this point. It's not necessary to have a friend function unless you want to access g.stars. If I don't make this a friend function, this will not be able to access g.stars, unfortunately. However, I would be able, if I wanted, to just use the indexing itself to just simply call g of index, and that would be totally fine too. You wouldn't need a friend function for that. But who knows, maybe I did want to modify stars somehow, and there could be some functions you write to do so, but in this case, I think we'll just leave it as it is and call it a video. So thanks for watching, and I will see you in the next one. Goodbye.